Welcome, everyone. Thank you for attending this Cochrane webinar. We are very pleased and very honored to be presenting this series of grade. There has been a lot of changes in grade, and they are related with that conceptual advancement, but also at the same time with the tools that we now have available to assess the certainty of the evidence. I'm originally from Santiago, Chile, so that's why a lovely city in the big south. So my conflict of interest, yes, I have no financial conflict of interest. I have received grants for guideline development. I'm a member of the grade working group. And there is two links there. One to join our community. We communicate news about grade mainly through the LinkedIn. We have tried several ways to do it and found that LinkedIn is the one who are best, which were best. And if you want to know more about grade, we are also, and this is about my next slide, we are updating the grade handbook. The grade handbook was originally developed by Jan, Holger, and some others at the beginning of the 2010, 2013. And then we now are updating with the latest 15 years of using grade and learning about how it can be more useful, more at the same time, more systematically applied, and new concept that has been developed. So I invite you to everything. The good thing about the handbook is everything. Grade papers are there are a lot of grade papers. So if you go to the book, you will have access to the latest iteration of every guidance paper. And also it's not here, but we launch a grade map where you have all access to all the grade papers, and at the same time with a clear distinction which remains valid and the ones who already were replaced by new guidance. So today we're going to talk about the certainty of the evidence. The certainty of the evidence is the confidence that the true value of an estimate falls within a specific range. This is the definition for depending what you're using, what kind of question you're using grade, with what kind of question you're using grade. The estimate may be different from simplicity. We're going to speak about an intervention question. So the estimate of the effect in this case relate to the estimate of the treatment. And what is important, I think this distinction is before 2017, the definition was the confidence that the true value, we know the true value. So it was a specific number, but now it's a far more pragmatic definition because we realize that it's not the specific value that helps us make decision, it's rather whether we know it's in a specific range. So we're going to talk about how this translates to practice. Today, we're not going to cover all the grade domains. I will exemplify how this new definition, the operationalization of this definition, deals with inconsistency and also with study limitation, but the same principles can be applied to any of the grade domains. So we say that in order to establish the certainty of the evidence, because now we are defining the certainty of the evidence in relation to a range, we first need to decide where are our thresholds, because the thresholds are the ones that define and circumscribe of range. So the first step is decide where are the thresholds. For example, threshold between trivial small effects, small versus moderate, and moderate versus large. Then we assess where the certainty of the evidence is, and then we move to the what you know. So if you see here, and this is also in the grade book, we have this 4-step approach. What we mean by the target of the certainty of evidence. And here we have an hypothetical meta-analysis with 4 studies and the pool estimate. And if you see, the pool estimate is in the moderate benefit range. So well, if the pool estimate is in the moderate range, then we are rating our certainty in a moderate effect. So in other words, we're rating how confident we can be that the effect of the intervention, let's say we're talking about intervention, is a moderate benefit. So the target is what is being suggested by a pool estimate, and is also what we will be rating the certainty of. So high certainty, so if we are rating, so if we say we are rating our certainty in a moderate benefit, then high certainty is we have high confidence that the true value of the estimate is indeed a moderate benefit. So after degree assessment, we are very confident that the true value is somewhere on the range of moderate benefit. What is moderate? What is the meaning of moderate certainty evidence? Well, say where there is uncertainty, so we are not completely sure anymore. So if we are rating the certainty in a moderate benefit, it may be the case, like in this figure, that we are not sure whether the true effect is moderate or small, but is around moderate. So it's close to moderate, but maybe crossing to another range. But remember that certainty was the confidence in that the true value is in a specific range. So if moderate certainty means we are not sure it's in that specific range on the one that is just besides. In the same way, low certainty evidence, the true value might deviate from the target of the certainty rating. So for example, may fall into a different range. In this case, in the figure, from moderate benefit, small benefit, or maybe trivial no effect. And the consequence is very low certainty, is that we really don't know if we're rating our confidence in some moderate benefit, there is so many uncertainties that we really don't know where the effect is moderate or can be small, trivial, or small, even small harm. So you see, the more farther away or the more uncertainty we know we can see regarding our target of rating, the lower is the certainty of error. So in a way, again, this is just consistent with the definition that the certainty of the evidence is of confidence that the true value is in a specific range. So this is the approach we are proposing in the book, and it's very similar to the all similar approaches that has been developed in the latest years. So first, you determine the number of thresholds where you're going to use, where those thresholds are, identify where your target, so which effect we are really rating our certainty. You evaluate the evidence, and then you decide whether to rate down or not. And this, I think, is the key part I think is different now, because we're making a clear distinction between evaluating the evidence, so evaluating how concerned we are to a specific domain of grade, and then deciding when to rate down. I'm going to go more on this. This is a nice figure developed by Carlos Cuello, in which you have the complete view of the grade assessment. So the grade assessment starts as by the study design. Randomized trial typically start as higher certainty evidence. Observational study starts as a low certainty evidence, although there is some if you're going to use a specific tool like Neumann, you can start observational studies of high certainty evidence. Then you assess 5 domains that can lower the certainty of the evidence: study limitation, inconsistency, indirectness, imprecision, and discrimination bias. And there is three domains that apply really only to non-randomized trial that may increase the certainty of the evidence. So one important consideration is that if you are familiar with the levels of evidence, grade is just an iteration and a further development of the levels of evidence. The levels of evidence were developed in the 70s and categorize the evidence just based on the study design. And the problem with that is not always randomized trial provide high certainty evidence, and not always the observational study provide low certainty evidence. So grade change that and allows us to really make a better assessment. We have 2 approaches now in grade. The approach 1 is observational study starts low certainty evidence. So the assumption here is a high risk of confounding is assumed by default. So we assume that all observational studies are at a high risk of confounding. So we rate down by 2 level. This is typically what we recommend for new users. It's not flexible because we are just assuming high risk of confounding. but that may not be the case. So that's why we have another approach. We typically require more knowledge and more time to do it. Where you say, instead of assuming high risk confounding and rating down immediately by 2 level, we can assess the risk of confounding, which is tools like roaming side. So this is more flexible, but required to know a lot more about observational studies and also more time. What happens typically approach 1 and 2 are very often give the similar results. So that's why approach 1 is still is useful, but sometimes we have found examples where the automatic rating down by 2 level seems to be inappropriate. So if you want a more, I would say, detailed assessment, approach 2 is a better way. One important consideration that in reality, if you think really about what is grade has only 5 domains, because the 3 domains that we say may increase the certainty of the evidence or are really mitigators of study limitations, because these 3 domains really reflect a low risk of confounding. So if the data show you a pattern like those response relationship of a large effect, what we're really saying is it's very unlikely to see a dose gradient, the response, or a large effect just by confounding. So confounding is likely not a good explanation for this result. So even if there are study limitations, they are probably not playing a big role. So in a way, these 3 domains are really mitigators of study limitations. So certainty assessment, 4 steps. We determine the number of thresholds, where these thresholds are. Then we say, where is the target of the certainty rating, evaluate the evidence, and determine whether to rate up or down. One important, and this is a kind of philosophical consideration, is you may be familiar with this, but in science, there is 2 complementary forces, the rationalists and the empiricists. So for example, in medicine, I'm an internist as well, medicine, so rationalists rely a lot in physiology, on pathophysiology. And empirics rely, well, yeah, that's all fine and good, but we want to see what the data shows. Well, the same happened with how we approach the certainty rating, because you will see that a rationalist approach will be if 75% of the study are coming from high risk of bias trial, then there must be something wrong with the result. That is the rationalist approach. So it's similar to pathophysiology. The empiricist approach will be, yeah, that's all fine and good, but we really want to see whether there is a difference between high risk of bias trials or low risk of bias trials. So the difference between the 2 approaches is the proof. For rationalists, we require logical premises. For empiricists, we require direct observation. So how this translates to grade? Well, for example, if you take the rationalist approach, you might think that 75% of the trials have risk of bias, then we need to rate down by 1 or 2 levels. Or if 75% of the trials are indirect, then we rate down by 1 level. And high square, for example, 75, so well, we write down by inconsistency by 1 or 2 levels. So this is a situation when you are using rationalist approach, but we think that maybe that's not the best way to do it. Because you can actually test now and this is greatly a benefit of this threshold, you can now test whether the magnitude of the concern, so in a way, whether there are difference between the high and low risk of bias trials or between the direct and indirect trials. So it's not the magnitude of the concern that should determine the number of levels we write down, but rather the potentially for realistically changing the result. So this, I think, is an important shift. We more and more say we need to grade the consequence, not the concern, because the problem with concern is something that is subjective, happens inside your head. But the consequence is something that you can actually see on the forest plot. So for example, I'm going to put in the first sample, study limitations. So this domain assesses whether flaws in the study design or execution could significantly affect our confidence where the true value intervention is. The primary method for assess this involves sensitivity analysis. So I'm going to go a little deeper on this. And also inconsistency. So I'm going just to use inconsistency and study limitation as examples here, but you can apply the same logic to any of the grade domains. So inconsistency is this domain evaluates whether there are substantial difference across study results. The primary method for this is assessing the visual inspection of the forest plot. A statistic like I-squared will serve as a screening tool. We're going to talk about more about that, and then we have a specific session about that, so which is upcoming. So stay tuned. So this is why we're separating step 3 and 4, and we're not, because this was before was this one big step. Now we're saying there are 2 different steps. First, we see whether are the historic study. For example, we assess study limitation. We use a specific structural approach to assess whether there are study limitation. For example, the tool risk of bias 2. We assess this first, and then we decided whether to rate down or not. So the logic is not enough to just see that half of the study had a high risk of bias. We then need to assess whether there is a difference in the effect between high and low risk of bias. The logic is when there is the estimate from high risk of bias trials is different from the low risk of bias trials, then we have a problem. But if they are concordant, so high risk of bias trial and low risk of bias trial showing the same effect, then we can conclude that risk of bias is not playing a role in the confidence that we can have that the effect is on certain range. We're going to see this in a very good example. I think this is a Cochrane review that I like. It was done for the colleagues from South Africa. It's low carb versus normal carb for weight loss and cardiovascular risk. It's a relatively new review. The main outcome, or the most important outcome for this review, for the trials included in this review, it was weight change of 12 months. There are 37 randomized trials, so like 3,000 people. It's a large review with a large number of studies, which allow us to play with the data, because that's another thing. The more data you have, the more details can you be, and the more detailed can be your analysis. So here we're going to apply these 4 steps: determine the number of threshold, determine the target certainty rating, evaluate the evidence, and determine whether to rate up and down. And I hope that by the end of the example, you will be surprised how we upload results in a different assessment. So the thresholds for this, because we need to define what is the minimal difference that we will consider meaningful, because we don't want to rely on statistical significance. And this is coming from consensus. The people dealing with lost weight and with nutrition, they long agree that 5% reduction of weight is what minimal there will you consider meaningful. So taking the baseline risk, so the weight of the control group, what with around 100 kilos, we can set some thresholds. So in this case, we're setting this threshold for the trivial versus small effect, 5 kilos, for the small moderate effect, 10 kilos, and for moderate large effect, 20 kilos. So this is based on this consensus. There is a Wojtek already gave you a very wonderful talk about how to set threshold. Now we have set our threshold. We see that the result of the meta-analysis, the pool estimates in weight change at 12 months is 1 kilo, favoring low carb versus regular carb. But we also said this, I think this example, one of the good thing about these examples is that this difference is statistically significant, but you can see it's below what we consider meaningful. So we have to conclude that this difference is really a no important effect. So we're going to be rating our certainty in a non-important effect. Step 1, we set the threshold. Step 2, we see where the pool estimate is, and then we decide to rate the certainty on where the pool estimate is. So now we're going to assess the style limitation first, and then assess whether there is a difference between the high and low risk of bias styles. And here you see the raw assessment, so the risk of bias assessment. You see that there's a lot of red trials. So we're going to compare the yellow versus the red. So we are going to assume for this exercise that the yellow are low risk of bias and the red are high risk of bias. And the high risk of bias is given mainly for lack of blinding and also because you missing out on that. And what is interesting here is that 74% of the information, so 27 randomized trials, 74% of the information is coming from high risk of bias trial. So in a rationalistic approach, you may be tempted to say if 75% of the trials are high risk of bias, then we should rate down the certainty by at least 2 levels. But the hypothesis here is that high risk of bias study may overestimate the effect. This is, in this case, this is the underlying hypothesis. But it's a hypothesis we can check. So we don't have to rely in mechanism alone. And in this case, you see that low risk of bias and high risk of bias both show that there is no important effect. You see there is a low risk of bias, a smaller effect, but both in the range of no important. So in another way, even if you have even the studies that at high risk of bias, that you can make the reasonable assumption that you may overestimate the effect, even those trials are showing that there is no important effect. So really, risk bias is not a serious concern when we are rating our confidence in no important effect. In this case, even that most of the errors coming from high risk of bias trials, we are not rating down certainty because we see that this bias is not playing any role in our estimation of the effect. How about inconsistency? This is another domain that we're going to use to exemplify this way of thinking. So we typically assess a statistic, we look at the forest plot, but the final assessment we need to do is for inconsistencies, whether all the trials are in the same range or not. And in this case, it's very interesting because the I-squared is 51%. So that may prompt you to rate down by inconsistency. We have a inconsistency p-value that is significant, which is not very often happens. So you say, well, do you have two statistical signals of important inconsistency? But if you go to see the results, I draw in this graph the no important range, and you see that all the trials, the 37, then suggest no important effect. So here we're saying a situation where the inconsistency is just statistical. The statistics are suggesting that we're seeing a different magnitude of no important effect, but all the trials suggest no important effect. So if all the trials give you exactly the same answer, although it's slightly different if we use a statistical test, then the results are consistent. And this is something we have realized over the years, that I-squared is a very useful screening tool. When I-squared is 0, you can be confident that no important inconsistency or close to 0, no important inconsistency is on the meta-analysis. But if you have I-squared even modest amount of I-squared, you don't know whether that inconsistency is just statistical inconsistency or is real inconsistency. And what we call real inconsistency is trials suggesting you different answers rather than just suggesting different degrees of the same answer, which is what you get sometimes with the I-squared. So in this case, we have weight change at 12 months, 37 randomized trials. If you see this meta-analysis at Cochrane review, you might be tempted to rate down by risk of bias. You might be tempted to rate down by inconsistency. But if you think about it, all the high risk of bias trial, the low risk of bias trial, both are suggesting no important effect. There is no real inconsistencies, it's just statistical inconsistency. So we can make the argument that this body of evidence is high certainty. We are very confident that there is no important difference between low carb and high carb diet, which after seeing this result is I think this is a very sensible conclusion. Want to know more about this approach? We have laid out the same kind of thinking for all the domains of grades, so you can visit them on the grade book. And yes, if you want to follow us, join our community in LinkedIn, that's the link. If you want to know more, that's the link to the grade book. Again, we share most of our news through LinkedIn. So yeah, that will be their presentation. So I'm happy to take your questions.
Thanks very much, Ignacio. One of the things I like very much about this work is, historically we used to talk about, well, there was some evidence that showed we did all this work to assess risk of bias and then we didn't do anything with it. Then we introduced grades, so we started to make sure we considered risk of bias in our interpretation of results, and much of the other information we collected along the way could be brought into that grade assessment. I think there's lots of claps going on, many people thanking you for a great presentation. One of the things that I think is a nice step here is, in addition to that work, we've done a lot of sensitivity, subgroup analyses, and again, I think we still sometimes lose the information from that. So I think this is very nice in that it really pushes people to use that information, but also to plan carefully those analyses. So there's a few questions, and I'm going to put them to you in a slightly different order because some of the things are very fresh in our mind. So the first one is from Andrea Bent, and Andrea's asked, do you recommend stratified meta-analyses for particular risk of bias domains to assess the impact of study limitations on the overall effect? And giving the example of perhaps where all the studies are at high risk of bias overall. So would you consider then stratifying by risk of bias domain?
I think it's a very interesting question. So when you face, let's this is part of the following session, but we can do a preview. So when you face risk of bias, or we call it study limitation now, because dissemination bias is also bias, right? And they really are the bias related with the study limitation execution, but that's fine. So let's say we're dealing with study limitations. You have three scenarios. One scenario is all the studies are categorized as low risk of bias, so there is no worry about that. So you can forget about this scenario because that's the easiest. Then you have two other scenarios. In one scenario, so you say, well, there is subpopulation of low risk of bias studies and a subpopulation of high risk of bias studies, which I think is the most frequent. And the other scenario is all the studies are high risk of bias, which also happens sometimes. I think it's less frequent, but may happen. So let's deal with the first. So one thing is, if you have the second situation, when you have a subpopulation of high risk of bias trials and low risk of bias trials, you can, and this is kind of a practical tool, you can see if there is inconsistency. Because if the tau square is 0, chi square is 0, then you know that any kind of analysis you will do will be probably not relevant. So if you have a chi square of 0, you will find that the low risk of bias trials suggest the same result that the high risk of bias trials. So that's a clue that if you have a chi square of 0, you can be confident that the results are concordant, so you are less worried about it. If your chi square is different from 0, so you have inconsistency, there is two things. One, you need to be sure not to penalize twice, so you don't penalize for risk of bias and then for the same inconsistency generate by risk of bias, because then you are penalizing twice for the same underlying factor. And the second is, okay, you want to explore this inconsistency, and you can, the typical first analysis is to explore overall, right? So overall risk of bias, see that if that explains it. But you can also make the point, if you are concerned, and this is something that you need to do in advance, right? So because you want to not avoid post-hoc analysis. So if you know that in particular field, lack of blindings, that's very serious issue, you might decide that in addition to the overall analysis, you want to explore specifically whether blinding is giving you a different result. And that's, as I say, I think it's perfectly fine. There is two considerations. It has to be a priori. And also don't forget that if you start testing it, I don't know, 20 subgroup, you eventually will find someone by chance. So if you think the blinding and a couple of more, so you need to restrict your hypothesis to some, not that many, but to few. And I think it's personally, if you have the suspicion that, and this has happened in the past, that blinding, for example, was a relevant issue, you can do that as well. And then you can see if blinding is playing out a factor. But the suggestion for us is, the suggestion we're now giving is, rather than say they're blind, their half of the study are not blind, is to test whether the blinding has a real impact of the effect estimate and see. right? Because that is more grounded on the something, two things in the actual data you have, and at the same time, it's something that we can agree on, because the problem with concern is something that happens inside your head. So it's very difficult to agree how concerned you are. The third situation is when you have only high risk of bias studies. And then here it's more complicated because you don't have any real data to compare, but then you can make a hypothesis. For example, say what happened if the high risk of bias studies are overestimating the relative effect by 2 times, and see if that changed anything. Because, for example, and we have tried this in the example that I showed you about low carb, you can do a lot of extreme assumption about bias, and still this effect is not important because it's so far away from the threshold, and it's so precise, the estimate, that at the end you have to have very extreme assumption to move to the other range. So another way to see the same is, even under extreme assumption, the results of the high risk of bias is still not an important effect. So that's another way, and this is probably, we are still updating the risk of bias guidance, and in the guidance we will probably suggest something like that. If you have nothing to compare, you can make reasonable assumption and see if that changed something, because we believe that doing that is more grounded in the data than just writing down.
Okay, your answer and I think presentation are stimulating lots of questions. There are 2 quite closely related questions, and I'll go to these first. Bernadetta has a question which really kind of speaks to your point. She asks why bother assessing the risk of bias of all studies included in a meta-analysis at all? Let's say we know that 1 of 10 included trials is of low risk of bias, heterogeneity is low, and there are no signs of inconsistency. Will the risk of bias of the other 9 RCTs change anything?
Well, there is 2 things. So one is, so I think I have 2 answers to that. One is the logical process you follow, right? So this assessment is something you do first, and then we move to the meta-analysis, and then you test your hypothesis. If you're going back and forth, you are at risk of rating the risk of bias in relationship with the result, which is something we want to avoid, right? Because you say, yeah, I'm going to not assess the risk of bias, see the result first, then go back. Then the problem is you may be assessing, or your risk of bias assessment may be influenced by the result, which is something we would like to avoid because we are humans, we are prone to bias, we don't want to do it. That's one thing. The other thing is that knowing whether studies are a high risk of bias is not only informative for the conclusion, because remember that systematic review are a very important piece to inform new research. And you realize if of 10 studies, only 1 is proper blinding, or 9 of them were very poorly done in terms of blinding, allocation concealment, follow-up, then you can make suggestions. Look, if you're going to keep studying this, you need to be doing better because we cannot have another high risk of bias study. So I think we need to assess the risk of bias first, because otherwise your assessment of the risk of bias might be influenced by the result, which is something we definitely don't want. And the second is, don't forget that the assessment is not only to inform the clinical implications of the review, also what suggests to future research. And there is a great group specifically dealing with providing very actionable suggestions and recommendations for research. And and those suggestions and recommendations will rely on the assessments of all the great domains. So I think those are 2 key important reasons to do it in this way and not the other way around.
Mm-hmm. I would agree with you. And I also think those who ask us to do reviews, funders and so on, they want to see it. They feel like they get a complete picture of the trial evidence, potentially to inform future research, but sometimes just to satisfy them. A related question, I think you may have touched on this already, but it might be worth answering it as a standalone. So Emma has said, for study limitations, if you investigate risk of bias via a sensitivity analysis, if you can't assess risk of bias via sensitivity analysis, would you still rate down? So for example, if all your studies were at high risk of bias, would your default be to rate down or not? And that's a question I have for you too, Ignacio.
Yes, so we haven't figured this we haven't figured it completely out, but we think rather than just rating down, because you have to think about how we deal with observational studies and randomized trials. So the simplistic way of dealing is to say observational studies are always high risk of bias. They are always risk of confounding. We always going to rate down by too low, which is fine if you want to do a quick assessment, but you want to do a professional assessment. You say, well, maybe just assuming two risk is better to actually test whether there is an using wrong result. So this is the same logic. If you are studies are a high risk of bias, rather than rating down. And the other thing is, how do you decide how to rate down by 1 or 2 levels, right? Because I'm very concerned. And I think it's more clear to see, okay, what happened if we make realistic assumption, where the true effect may lie under this realistic assumption, and how far is this maybe the true effect from the target of the risk certainty rating. So in a way, you say if it's very far away, so your realistic assumption give you may you cross a lot of threshold, then you say, well, we're very worried about risk of bias. Or and the opposite result will be, yeah, we make even very extreme assumption. We are still in the same no important effect range. So we are very confident that risk of bias is not playing a role. And this may happen exactly with the same distribution of the percentage of high and low risk of bias. So at the end, we think testing reasonable assumption is a better way to do it because it's grounded in data, and also give an unambiguous way to rate down the certainty of the events, which is something we are really, really working on. Because one of the problems, especially if we want to create tools to help this assessment, we need criteria that can be applied unambiguously, can be checked. And the problem is, you say, well, if you're relying on the amount of concern, that is not really checkable, right? Because how are you going to do it? So that's a problem.
Yes, it is a problem. So there are questions related to a few other things. One of them is was prompted by one of your responses, but is a step back a little bit. So Young Gao said, but the MID might change. So you've illustrated your example thinking about study limitations using particular MIDs. The MID might change our assessment for imprecision and inconsistency possibly too, e.g. if we have 3 kg for a small effect, 5 for a moderate, 10 for a large, will the judgment be different? How could we get all related MIDs in a commonly accepted way? I think there are two things there about will the judgment be different, and then the very thorny question about coming up with acceptable thresholds.
Yeah, so I think it is one of that has become very clear when we start using explicit thresholds is the certainty assessment. So it's not only the certainty assessment, the interpretation of the results, the conclusion we're going to draw, whether this fact is meaningful or not. And the certainty assessment is related with your threshold. So the problem, what happened before, and I still happening in some degree, is you see the results, then judge whether this is meaningful or not, and you do it implicitly and post hoc. So the only thing we're saying, because the interpretation of the result, the certainty assessment will all depend what you consider meaningful, what is a small effect, what is large effect. Then is to better than doing this way, post hoc and implicitly, let's try to do it a priori and explicitly. And of course, the certainty assessment will change if you have different set of thresholds, and that is a feature. It's not a problem. It's a feature because it's increased transparency a lot. So the second question is how we can have reliable threshold, and then we have the great guy proposing some methods, but I think over time you can read, because the thing is threshold are arbitrary. Yeah, because it's the measurement stick we're using to measure effect size, and measurement stick are arbitrary. There is nothing natural about having a rule of 1 meter. It's something we decide we're going to use or to measure our distance, and now the threshold is something we have decided we're going to use to measure effect sizes, and ideally this will be derived based on empirical data with broad consensus. So I think over time we will get very, very good thresholds. there is some of there already. For example, in the field of nutrition, they are very clear how much weight you have to lose to be meaningful. There is also, for example, we have found that for some fields in medicine, people already agree on what we'll consider, for example, cancer, what we consider a meaningful effect in survival. So there is plenty of people that already agree, but also ideally this will be based on data, informed by what decision makers think, and also ideally by patients as well.
Yeah. Thank you, Ignacio. Something we debate at length and convince people of, that you're better being explicit about your thresholds than not, for many reasons. Related to the question of thresholds, I think not necessarily the central theme of this presentation, but nonetheless, we can't apply these principles without thresholds. Celeste noted us a question about what is probably the more common scenario in Cochrane reviews at the moment, where we use only 2 thresholds, and just asking a question about, is there a recommended term to name this threshold when effects are no longer trivial? Would something like above or below a meaningful threshold be acceptable? So really just thinking about how to distinguish that from thresholds related to effect sizes.
Thank you very much. I first have to acknowledge and thank you, Celeste, for your wonderful review. Has made us think a lot, and we have been using it all over. So yeah, we are very thank you for your review. It's very, very helpful and very useful. So so the problem with true threshold, which you may think that simplifies things, but at the end is you may end up in troubles. Is the amount of detail you want to have. So if you have 6 thresholds, you have more detail. You have a more nuanced assessment. If you have 2 thresholds, the problem with the threshold is we are saying every time you cross a threshold, you lose a level of certainty. So the problem with having 2 thresholds is there is no reliable way to rate down by more than 2 levels. So if we agree that sometimes risk of bias should be, and this is something that we say, sometimes risk of bias or inconsistency or any of the grade domain is so serious that we should be able to rate down by 3 levels, which is something that's now possible for any grade domain. And we'll say that explicitly on the grade book. The problem with using the 2 threshold is there is no reliable way to rate down by 3 levels. So in a way, you are using a 3-level system. So use 2 threshold grades goes from 4 levels, low, very low, moderate, and high, to 3 levels. I don't know what to call it, but you are losing details. So that's why I think it may be simple, but at the end it's more complex because you cannot automatize and you run in all sorts of troubles. The other thing is when you have 1 threshold or 2 thresholds, you can easily build the others because we have some formulas for that, so it's easy to build the others. We tend to call it, to avoid confusion, we tend to call, for example, when you use 2 threshold, you use the threshold between the trivial and small effect. So in a way, if you want to add more threshold later on, this will be the same terms, and we try to avoid calling differently. Also, there is some great guidance called partially contextualized, fully contextualized, and at the end it was a disaster because it was not clear what meant. So at the end, well, let's say the number of thresholds you're using and where the thresholds are, and let's try to use consistent name for those thresholds. So it's a kind of easier. So this is the core approach, and I will encourage you to, if you already have 2 thresholds, I encourage you to try out put 2 more, and you will see that at the end for example, if you want to fully automatize a certainty assessment, which is something we are very close to do, you need the 6 threshold. It's something that cannot be done with 2 threshold because you need a lot of judgment, which is something we want to maintain, but at the same time facilitate.
Yeah, one thing, Ignacio, that we get asked about, though, that I think is somewhat challenging is when we move to 3 thresholds and we start to express, for example, our certainty in a large effect, that effect might still be large enough to be of importance to people who receive a treatment, but we might only call it a small effect. If we end up with low or potentially very low certainty in that effect, do you think we have a communication challenge in still describing that we have a potentially beneficial effect, but we have very low certainty that it's a large effect.
Yeah, so there is a couple of issues. So there is large effects there is a specific rules that apply to large effects. So for example, this is a well-known situation when you have large effect based in a low number of events. Then you say this is maybe just chance, and this is a scenario where you typically say this is maybe just chance, maybe dissemination bias. So having a large effect with a few number of events is a concerning issue. We have flagged this issue, and every time you have this situation that should be a problem, you should analyze. The problem, for example, we have in two thresholds, there is no way to say when an effect is large because there is no definition for large effects. So some of the rules that we have developed to flag problems in the evidence will not apply. And that's a reason that is so difficult to do it with two thresholds. The good thing about for example, large effect and having three thresholds, you can judge whether this large effect is precise and you are moderate or high confident in this, or you think, well, the evidence suggesting a large effect, but this effect is so imprecise that actually could be a small effect or even a trivial effect. And then the number of levels for example, let's say the only limitation is the precision, the number of levels you're rating down to from large effect, just counting the number of threshold cross, which is the matter of another session, but let's say it's large, moderate, small, it's already, you think you're crossing 3 thresholds already, large ones. So you're rating down, you're penalizing. So 3 more thresholds need you to be more cautious and more conservative on the rate estimate. So another thing, if you're using 2 thresholds, overall, on average, you will have a higher certainty of evidence, which is something we would like to avoid as well.
Yes. Yes, I think the thresholds are definitely our friends in many circumstances, and you've addressed that very well. There's a few questions here that are probably more operational things, but one of them definitely has challenged many people who work with non-randomized studies. So Yafeng has asked, most observational evidence ends up as low or very low in grade. What is the proper way to view these findings? Good luck answering that.
Yeah, but that's a reality, no? So yeah. So that's a reality. There is a lot of uncertainty in most of the research, and I think that's a natural thing. And if you can say this is a good way, because if we are certain about everything, then we don't need more research because we already figured everything out. So in a way, I think the reality of clinical practice is there a lot of uncertainty about the effect of intervention, and grade is just reflecting this.
Agree. Another communication challenge, I think, for decision makers to know they can make decisions in the face of low or very low certainty evidence. Time for maybe just a couple of very simple questions. I know there's a couple of more complex questions that we won't get a chance to answer here because we do need to wind up very soon. There is a question, is this true that there is absolutely no grading up for RCTs in the case of dose response gradients?
So in the case of dose response gradient, there is a guidance paper about that. So you mean the specific up to that, or a specific?
Yeah, just asking, can we ever do it?
Well, there is and Hassan made a very compelling argument that's a full grade guidance. The just focuses on those response gradient and when to be confident about this relationship and when this just mean random error or confounding. So there is also important that when you have a dose response gradient, you need to assess some things, right? Because that may happen just by chance, or those relationship might appear just as a result of confounding. If the confounding is also a dose response gradient, you will see this. So I think it is a full grade guidance, and you can search it, and this is very, very well operationalized, I would say.
And that is a nice point at which to say that if you are looking for grade guidance, there are 2 places you can look. And historically, you may be familiar with looking at the Cochrane grade web pages. So there is a full list of all grade papers on the Cochrane website. So if you look up Cochrane Grade, you will see links to those pages. But more recently, really important resource that you will find by going to the link that Ignacio provided to the grade book, there is a new grade map, and I really encourage all of you to go and have a look at that. It's an interactive map, and you can find whatever grade guidance you need, whether you're doing an intervention review, diagnostic test accuracy, prognosis review, whether you're using grade simply for a systematic review or for making recommendations or decisions, you'll be able to find the most up-to-date guidance on each of the topics, and you'll be able to navigate your way to the paper that Ignacio talked about by Hassan Murad and others in the working group on dose response considerations when you're grading. I think we have 4 minutes to go, so I probably should draw things to a close now. There are a few more questions we could ask. I'm not quite sure whether we have any forum to answer those questions, but I am fairly confident, given the nature of the questions, that they are questions that you could bring along to future sessions, because they do. One of them relates to the assessment of inconsistency, for example. Another relates to risk of bias, and that might be well placed in the study limitations webinar. So on that note, Ignacio, I'd like to thank you very much for a wonderful and very stimulating presentation, really urging all of us to make use of all the information we collect in our reviews and to plan carefully to be able to do these sensitivity and subgroup analyses, so we can really be confident that we're rating down only based on the impact of our concerns, not on the concern itself.